podcast. This is Mr. White.
And Mr. Sadler.
We're going to do a little AP Plus 4-2 today. And we're going to talk about your desire to see linear graphs. So, Mr. Sadler, are all relationships in science linear?
Of course not.
So, one more time, are all relationships in science linear?
No.
Okay, so there's this mythical belief among science students everywhere
Right.
that if we just fit a line to it, that the points will magically straighten out and the world will continue to work as we believe it should.
Every graph is linear.
Every
right?
graph is linear. And please make sure you put that on the screen if that's false, okay? So you guys today in the investigation, you did a couple things. You had these funny shaped tracks, and you measured, we talked about GPE and KE, and you measured some speed as it went through the bottom. And then so that was your track experiment. And then you did a pendulum experiment. I love the pendulum, where it swung back and forth, and you talked about its GPE and its KE. And you were asked in the investigation to create some graphs.
Correct.
Okay.
First a data table of
Right.
velocity, height, and then a graph.
Right, so a data table, well, that's interesting. And if you were to just take your data and make a velocity height graph, would it be linear?
No.
No. And so what you would see if you were patient is that it would be quadratic. And there's a lot of reasons why you know it's quadratic, and we alluded to them in the first podcast where we said that the v squared was equal to 2gh. And if you ignore the squared sign, you would want to make a linear graph.
Correct.
But of course, you can't do that. And so what we need you to do, if you would like things to be linear, is you need to square the velocity. And if you do that, well, then you'll be happy.
Correct.
Because you will see something that is in fact linear.
Correct.
And so as we look at that, because v squared is 2gh, and v squared is along the y and h is along the x, the slope of my line must in fact be
Gravity.
not just gravity, but 2 times gravity. So the slope should be 2 times 9.81, 19.6-ish,
Right.
if you did a good experiment. And so number 1 there on the AP Plus says, calculate the slope of your graph from the pendulum data and record its value. Okay, so what do you think? Should this be the pendulum graph?
It should be a little bit steeper than that, right?
Yeah, I've got mine as a 1.
But yeah, it should be the second graph, not the first.
Right.
Right.
And should this be the general shape of my roller coaster graph or my track graph?
Yes.
Yeah. So it asks you to calculate the slope. So what we would like you to do is to take your data. I'm a big fan of Excel and hacking your way through some Excel. You could use your TI-84. You could plot those points and have your graphing calculator do a best fit line. But make sure you plug in the v squared data. If you plug in the v data, you're going to be very disappointed.
Correct. And so if I'm going to do this experiment, I only need 1 or 2 points, right? That should give me a perfect graph with 1 or 2 points.
That would be a wrong answer.
Right.
Yeah. So what we keep begging students to do, of course, is to do multiple experiments. Do not rely on 1 or 2 data
So
points.
I think what it says is try different lengths of string, but you might want to try multiple trials with different pieces of string. And then also, I always know what 0 is here, right?
Yeah. What is 0 here?
It's 0 height is going to be 0 velocity.
Oh, is that what this says?
Yes.
Yeah, that's weird. So, and actually both graphs say that 0 height is 0 velocity,
If I raise the plumb bob up to 0 height and release it, it's going to be 0.
It's not going to go anywhere.
Right.
Right. Yeah, so 0 is the bottom of the pendulum's path. 0 is the bottom of the track.
So I know one data point. Okay, so that should be a good starting point.
You would think. You would
Right.
think. So we're begging you then maybe to talk to a couple other groups. You have friends taking physics to do number 2. Compare the value of your slope with those of others in the class. We've already kind of given it away, haven't we?
Right.
2G. So let's see if you did a good experiment. Compare your experiments to others.
But it's a nice way to test how valid your data is. Too.
Yeah. And then they ask you to do the same thing for your rolling ball experiment down the track as well. And I think that this type of graph making is positive. That you need to work these sorts of things out. You need to be comfortable with seeing something like this and saying, okay, well, if I want it to be linear, what do I need to do to either my y or my x term, and to get to a place like this?
Any testing over science material, they always have graphs, so it helps to actually do graphs and graph it yourself.
It's weird, though, on the test that I keep writing. Let's see, I've written 3 tests, and these graphs keep appearing. There's some DT graphs that show up.
Right?
Uh-huh.
And VT graphs.
Yeah, and some of them look like this.
Yes.
Yeah.
And AT graphs.
Mm-hmm. And then there's some VT graphs. That's also strange. Yeah, they look like that. Uh-huh. And these are the only valid graphs, by the way.
Right. The ones on page 64 in your book. I can't believe that I know the page number.
Yeah, yeah. And then there's this graph here for AT, and I suppose I'll have to superimpose that there. There's that. So I haven't done us any favors, but if we had to match these up, let's see. 0 acceleration is constant speed, so those guys go together, and constant speed would be there. Okay. Right. And these 2 guys would go together. That's nice. And there we go. And then this guy's sort of out on an island because the thing's not moving.
Right, absolutely.
I suppose I could make a
so
VT.
The velocity equals 0.
Yeah, I could make a VT graph of that. This would be this guy here. Okay, so, and no acceleration. So I made a mess of that, but we've been seeing this now since the early part of September. These graphs keep showing up on the test.
So do you suppose they'll be on the test this time?
I don't know. What do you think?
No, probably not.
Probably not.
We're all done with graphing.
Yeah, once again, post a sign on the pod saying you should learn these graphs because I've asked questions about work and energy and momentum, force, position, velocity, acceleration. All the stuff we've talked about can relate right back to these graphs.
Correct.
So I believe that covers it. Signing off, this is Mr. White.
And Mr. Sadler.